Alright, so the reason we've been working on negative and fractional exponents all week long is so that we can learn how to solve equations with them. So when solving equations with negative and fractional exponents, it boils down to our previous lesson, which was evaluating numerical bases with negative and fractional exponents. So as long as you can evaluate numerical bases, there's going to be no problem with you. So each solving equations example that we've had this year, whether it was an absolute value, whether it was a radical, the first step was always to isolate. So that's exactly what we're going to do here. Step one is to isolate the term with the negative or fractional exponent. In this case, the term with the negative and fractional exponent is this. So that's the term we're going to have to isolate. In order to do that, I'm going to subtract 2 from both sides of the equal sign. So therefore, we have x to the negative 2/3 equals 4. Alright, so step 1 is complete. We've isolated the term with the negative and fractional exponent. So now what we're trying to do here is change this to x to the first power. Eventually, to solve an equation, you want x to the first equals. That's the goal of solving an equation. That's when an equation is solved, when it says x to the first power equals. So how can we possibly change this negative 2/3 to a positive 1? Well, we're just going to follow some properties of exponents, and if we recall that when you raise a power to a power, you multiply. So we're looking for the multiplicative inverse of negative 2/3, which is its reciprocal. Raise each side to the reciprocal power. Just remember that the reciprocal of a negative is a negative. And just watch how I raise each side to the reciprocal power. I'm going to get rid of this in case I need a little more room. So I'm going to copy the exponent, and I'm going to raise that to the negative 3/2 power. Now, I did it to the left side of the equal sign. That means I have to do it to the right side of the equal sign. 4 to the negative 3/2 power. So now, what is x to the negative 2/3 to the negative 3/2? When you raise a power to power, you multiply. Anything times its reciprocal is 1. So I didn't really have to erase that. So x equals 4 to the negative 3/2 power. And now we just have to evaluate some power over root. So let's take the square root of 4, which is 2. So x equals 2 to the negative 3rd power, which means x equals 1 over 2 to the 3rd power. Negative exponent means take the reciprocal, and 2 to the 3rd power is 8. X equals 1 over 8. So step 3 here. Evaluate the numerical base. So, pretty simple procedure. The term that has the negative or fractional exponent, get it alone. Raise each side of the equal sign to the reciprocal of that power, and then evaluating any resulting numerical basis. Here's another example. Well, there's 2 examples. We'll do one at a time here. Cover this up as to not distract you. So, in this case, the term with the negative exponent is the x term, not the 2. We'll have to isolate the x term. So in order to do that, let's add 1 to both sides. So we have 2x to negative 3/4 power equals 16. Still not isolated yet. Still 2 there. So let's divide by 2. So now we have x to the negative 3/4 power equals 8. Now we're isolated. Let's refer back to our steps. This is all step 1. Isolate the term with the negative exponent. Step 2 was to raise both sides of the equal sign to the reciprocal power. So let's rewrite what we have and raise it to negative 4/3 power. But if we're raising this side to the reciprocal power, we also have to raise this side to the reciprocal power. So it's just 8 to the negative 4/3 power. Okay, so let's just bring that up there. we end up with x equals, because when you raise a power to a power, we multiply, and anything times its reciprocal is 1. And we'll just evaluate some power over root. The third root of 8 is 2, leaving us with a power of -4. Negative exponent says, take the reciprocal, 1 over 2 to the 4th power, and 2 to the 4th power is 16. So x equals 1 over 16. So now, take a look at this example. Step 1 was to isolate the term with the negative or fractional exponent. So you may say, oh, we have to divide by 2 first. Not in this case. In this case, the term with the negative or fractional exponent, in this case fractional, is both 2nx. So it's already isolated. So we just have to square both sides of the equal sign. Let's compare this to something that we have solved already. We've learned how to solve that equation before. This was back in October. Isolate the radical, square both sides, and solve. So now we're just expressing the same equation a little differently. This is radical 2x. The term with the negative and fractional exponent is isolated, so let's raise these sides to the reciprocal power. 2x to the 1/2, let's square that. But that means we have to square the other side too. Also, not 2. So 1/2 times 2 is 1, so this side leaves us with just 2x equals 4. And now we can divide by 2. X equals 2.